So what type of graph would this be? It's going to be a hyperbola. So what I like to do a lot of times in these is just identify graphs. So we know this is a hyperbola. And even more than that, is it a horizontal or a vertical hyperbola? Vertical. Okay. And then we also had some things for dealing with the connection between A, B, and C. What was that formula when we had a hyperbola? Right, A squared plus B squared equals C squared. Okay. Now, these relationships between A, B, and C are true, even though our center is not 0, 0. So what I like to do is identify what the center is first, and then I can still do my distance A to get to the vertices, and use the B, in this case, to get to the slant asymptotes and those kinds of things. So we're looking at this. What is this, the new center? Right, 2, -4. What you want to do is look at basically what number before, when it was just x squared, you could put 0 for x to get 0 squared. Now you have to put in +2 for x to get 0 squared, and you have to put in -4 and for y to get 0 squared. So 2, -4, so what I would do is just plot that. So 2, 1, 2, 1, 2, 3. So our center is 2, -4. And then that doesn't mean the center is going to end up being part of the graph. It's just when you start talking about A as being your distance from the center to the vertex, when you start at the center. What's the value of A in this problem? That's 3. Because we look at what A is distance to the vertex, and the hyperbola, the vertex goes along the expression that's positive. So A squared is 9, B is 3, and B is 5. Okay, so let's see, we know what the vertex is, or what it, we can figure out what it is. So we're starting at the center. Are we going left and right 3 from the center, or up and down?
Up and down.
Up and down, right? Because it's, if you look at it, the 9 was with the y part, so that tells us we're going to move 3 on the y direction. So it's 1, 2, 3. So I'm going to call this V1 for vertex 1. Let's see, if we were at 2, -4 and went up 3, now we'd be at 2, -1. And the nice thing is it's on the graph, so we could count it if we think through the coordinates. Let's see, down 3 from the center, 1, 2, 3. So our V2 is 2, and we're at -4. Go down 3 more, -7. Another important part of your hyperbolas were the slant asymptotes. Okay. So, Lucas, how far from the center do we need to go left and right to get the sides of the box? Not sure. Well, what's the B value? Okay, so how far do we need to go from the center to get the sides of the box in this case? Okay, your box is always formed by going your distance A and B in the appropriate direction from the center. In this case, A was a vertical distance because our vertices were along the y. So that means the sides of the box, if I slant asymptotes. And obviously if I used a ruler, these would be more accurate. I'm just going to sketch it for demonstration. Okay, so our slant asymptotes, well, it would be nice to have the equations of that slant asymptote. By diagramming it out, it's easy to see the slope. So I create this slope here is 3/5. Now on your activity, you always had y equals plus or minus 3/5, right? But that was when I went through 0, 0. It doesn't go through 0, 0 anymore. It goes through, I like to use the center point a lot of times, the 2 -4 in this case. So let's see if I can find slope. Y minus -4 or y plus 4 over x minus 2 equals our 3/5. Rise over run is subtracting the y coordinates, subtracting the x coordinates equals the slope we found. Well, point slope, just multiplying both sides by x minus 2, and get y plus 4 equals 3/5 times x minus 2. So there's our equation of the slant asymptote. And it'd be very similar for this one. Except now it's the slope for the one that, what's the slope there? -3/5, right? Because now you're going down 3 over 5. So we have basically y plus 4 for x minus 2 equals -3/5. Multiplying both sides by x minus 2 gives y plus 4, -3/5 x minus 2. And we could simplify that if we wanted to get the slope intercept form. I wouldn't take the time, I'd leave it point slope, because it just said find an equation of your asymptotes is one of the key characteristics. Let's see, so we have our vertices. We have our slant asymptotes. What's another important thing with these hyperbolas? What's the other? Yeah, the foci, the focus points. Okay, so we need focus. Well, let's see. A squared plus b squared equals c squared. So we'll just use that. Find c. Well, 9 plus 25 equals c squared. So that would mean 34 is c squared. So plus minus the square root of 34 is c. Now, if you're using a strict definition of c as far as that is always a distance, obviously you'd have just the positive square root of 34. Did I do something wrong, Carlton? You gave me a strange look there.
Oh, no.
So now if you're thinking of it, what you're doing on the graph though, sometimes it's useful to think of the plus and minus part. So from the center, you're going to add the square root of 34 to get one of your foci. And from the center, you're going to subtract the square root of 34 to get your other foci. Square root of 34 is pretty close to what? Yeah, it's pretty close to 6. So even though I don't know exactly what it is, I could get a pretty good idea of where it's at on the graph. So at the center, and we're going to go up almost 6 because your foci in line with your vertices 1, 2, 3, 4, 5. There's 6. Just a little bit before. I'm going to call this F1 for foci 1. What's the x coordinate? 2, yeah, because you were at 2, -4, and you went up. Okay, well, you were at -4, and you went up a distance of the square root of 34. So I would write that as the y coordinate being -4 plus the square root of 34. Okay, I wouldn't bother to get the decimal approximation because it's not neat. and then similarly to get that two. So start at the center again, and now you're gonna go down almost 6. 1, 2, 3, 4, 5. There's 6, just a little bit before. 2. We didn't go left or right, so it's still at 2. We started at -4 on the y, and went down. Square root of 34. And then the last thing to do would be to draw on the branches of the hyperbola. Keep in mind that the hyperbola goes through the vertices, and it should approach your asymptotes. So we'll make it close to the asymptotes, make sure it goes through the vertices, and we get a pretty decent sketch of what it looks like. The way we define that A, B, and C still applies, just we start with a new center point. And we do everything from that center point.